Hi, Shrikant. Good morning.
Hey, hi guys. Good morning.
Shrikant, just wanted to ask a question here.
Yeah,
I mean,
sure.
regarding this data science, since we are just doing a sort of a course here. I mean, is there
Mm-hmm.
any way we can write some sort of a certification, so that it will improve our credibility or something like that? Any certification you would recommend?
Yeah, see, when it comes to data science as a subject, so there are various institutes and colleges, which give this certification. So, for example, IIT gives, Triple IT gives, ISB gives. Okay, so but these are like pretty extensive courses, may span for an year or so. Other than that, there are various technology companies like AWS, Azure, IBM, um, SAS. So they also provide the certificate, but you have it would be more confined to their products. So, for
Okay,
example, if you go for data science specialty course on AWS, then definitely they will cover the data science aspect also, but whatever the practical exercises would be on AWS only. So they will teach
okay,
you the services, they will teach you how you can, train the model on AWS, how you can deploy it, all that, or, how you can leverage various services, AI services of AWS. So all that will be covered. And if you are certified, that means, okay, you know data science and you also know the AWS services. So on the tool specific certifications would be there.
okay.
Right. But apart from that, like even our institute also will provide you a kind of certificate if you ask. So they are like, multiple training institutes, so they have their own certifications. And then you have this online courses, right, on Coursera, on Udemy, and various other platforms. So they also provide certificates.
No,
It
something that we can put it on resume. That's what I'm
Yes,
asking.
yes, 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 you can definitely. So whatever I told you about, everything you can put it on your resume. Okay.
So yeah, yesterday decision tree topic was, I think, comparatively quite easy to understand. It's not very
Oh,
tough.
yes. Yeah. It's easy and it is pretty good algorithm because mostly if you uh, see, as I mentioned, firstly you need to understand the problem statement to select the right algorithm. So, firstly, when you understand the problem, if you see that it can be solved through some kind of rules. Okay. So if you understand the loan approval process, you will understand that they will have a checklist and they will check every condition one by one, and then finally they will arrive on a decision whether a loan to be approved or not. If you get this kind of a scenario, then decision tree is a very good algorithm which would fit to that particular problem. Sometimes even we have used this decision tree to just to come up with rules, to frame rules. So for example, yesterday we have seen about that use case about drug A and drug B, right? So if you examine that entire tree, in every decision node there is a rule, right? So you
Yeah.
can even create a checklist or the rule list, and then you can give it to your customer, okay, to your business, saying that okay, you can follow these rules, okay, to do it. So in one of the uh, project, okay, we just had to come up with a proper rules, and then we have to rank those rules which is more important. So for that, we have used decision trees.
Okay. So one question here, Shrikant, like that
Uh-huh.
for there were two ways, you said two or three ways. One was entropy, another was Gini index. So
Yes,
entropy can split in more than two, while Gini index is only for binary split.
binary split, yes,
So
yes.
let's say you have something where you can only split in two. So still you would prefer to go by Gini index. You should not go by entropy then in that case.
No, no, you can use entropy for binary as well. See, entropy is
Okay.
like a multi-purpose kind of a measure. You can use it. in any of the scenarios. So usually we go with entropy, but if it is a binary problem, then you can try Gini as well. So if you look at the
Okay.
formula, it's more of you will get a similar kind of a score. It's not something, in if you use Gini, so Gini is giving you a high score and entropy will give you a low score. It's not like that. So there would be a little difference, but mostly the the whole method behind these two measures are the same. Okay. If the Guinea is low, then the entropy would also be low.
Okay.
It's just they given the choice for us. Just a second.
So today we'll be discussing the Python.
Yes, today we will discuss about Python. Yeah, before going there, let me share this. Okay, so this is the scikit-learn page of decision tree. Okay, so here if you see that we will have multiple parameters. Okay. So here is the criteria on okay where you can select Gini or entropy. So here it is written, right? You can use Gini or entropy, or even you can use log loss. So this is just like the choices I've given. But even you can try that. You will not find much difference in the tree. Okay, even if you change any of these parameters. So default by default it's Gini. Okay. Um, then we have as I mentioned yesterday that. The tree has to, you have to limit the tree size. Otherwise, it may lead to a overfitting, right? So there we have certain parameters which you can pass to this particular model, to restrict the length of the tree. So you can give maximum depth, like what level of depth, you are allowing that tree to grow. Okay, so if you say 5, then it will just take 5 different branches and then it will stop. Okay, then here we have minimum samples split. So only in any node, if there are more than 2 samples, means more than 2 observations in any node, then only it will go ahead and split, otherwise it will not split. So minimum samples leaf. So in the terminal node, this is the minimum number. Okay, uh, which it can take. So by default, it is 1. So that's the reason it will keep on growing till it achieves a one single observation in the leaf node. So if you put minimum as equal to 1, then it will grow to the maximum size. So the default one, if you are seeing that these all will allow this tree to grow to the maximum size. If you want to control, then you have to put some number here. Okay, you have to specify what depth of the tree you want. You have to increase this number and this number also. Okay, so that it will limit to a particular size at a particular size. So these are the most important ones, maximum depth, minimum samples per split, and minimum samples in the leaf. Okay. And this we will discuss CCP alpha. This is the complexity parameter, which I mentioned. Okay. If you grow a complete tree to the fullest, then we can use this particular uh, parameter, to prune the tree from the bottom. Okay. So that, you can use. Even you can use maximum leaf underscore nodes. Instead of that, we better we use this one, minimum sample. So you have some description about each of these parameters. Okay, so you can go through this also. So these are the basic hyperparameters like criteria. The splitter means the best. It will find out the best attribute what we have discussed. Okay, at every split. And these are the three most important parameters. And this is something you have to remember because in the interview, people may ask, like, how you will fine tune the decision tree algorithm, and decision tree being a more popular algorithm. So this question may come up, okay, in your interview. So maximum depth, minimum samples, and we will see that how we can. Now your question would be, what would be the optimal number, to use in this particular parameters, which would give you the better model. So there is no direct answer to that, that you have to use this and this. It's something, you have to try various combination, okay, and see that which combination is giving you the better results. So we have certain techniques like grid search, we have random search, okay, which we will discuss. That's something you can try to come up with a best combination, which will give you the better model. Okay, so now let's get into a use case. Okay, so we will take the same data set so that you can relate to that particular use case. Now, this is more from a life science perspective, uh, and yes, people are using this kind of applications to even to recommend medicines and even to recommend some kind of a treatment. So this is a very small scale example where we are not taking many features. We are just taking five features because I want to show you the tree, how it is formed. If it is like more number of features, the tree looks very complicated and you won't be able to understand. So that's the reason I took a very small example. But this algorithm is capable of scaling to multiple other features also. So now this is the data. Here we are. The only thing what we are doing is we are segregating the data into input variables and the output variables, and then converting that into an array. Then here what we are doing is we are doing the label encoding. This is another different kind of pre-processing. So here this decision tree would not able to understand the text, okay, and any of the algorithm, because these are all numerical computation which occurs behind the scenes. So wherever there is a text values, you have to kind of convert that into a numerical value. So as this is a categorical variable, I'm keeping that as a categorical variable. But what I'm doing is, instead of these string values, I'm converting that into a number. Okay. So for that, you have this in pre-processing, sklearn pre-processing module, you have this function known as label encoder. So as the name suggests, it will encode the labels. So in this particular column, we have two labels, female and male. So it will encode with some number, okay, numeric number starting with 0. So either of these labels will be encoded as 0 and 1, right? So that's how, I have encoded all these categorical columns. It's just like, you call this function and just say fit and mention these two categories here. So when you say fit, it will give some numeric value to F and to M, right? And then you go and transform that particular variable. Similarly for this column and similarly for this column. If you do that now, see, this is how oh, sorry, what happened? Once again, guys, somehow it got closed. Frame. All right. Sorry about that. Okay, so yeah, so that's how I have encoded all these columns. Now, if you see, compare these two data. Yeah. So, okay, so if you look at this data, so earlier it was F, M, M, F, F, right? So now it is 0, 1, 1, 1, 0, 0, right? So it has labeled uh, every category by some number. Okay. starting with 0, 0, 1, and 2 like that. So it would not be a problem in what happened, man? Why is it coming like this? Yeah. Okay. So in Dictionary, it would not be a problem like what number it is labeling to any particular label. It's encoding on and off on any label because it's more of a rule based, right? So even in any of the node, it will just take one particular attribute and it will create some condition on top of it. So here we are not giving any kind of a weightage. There is no equation as such. So it's okay, if you go and label that um, by some number. So this is kind of an important step in decision tree which you have to consider while pre-processing the data. Now that's what I did it for the input features, and for the output feature, I'm just converting that into an array. That's all. And now I'm splitting the data into train and test. So this we have already seen, right? So this is the function which we generally use to split the data. So here I'm going with a different size now. I'm going with 30% test and 70% training. Now here comes the model training. So here, as it is a binary, I'm going with Guinea, which is a default. Otherwise, you can just go and you can type entropy here like this in double quotes. And here I'm also mentioning the depth. So here I'm controlling the tree. So you can play with that. So in this case, I'm just putting as maximum depth equal to 4. You can change it to 3, you can change it to 5 and see that how your tree is, uh, being created. So now why it is important is, as I mentioned, one way is like computationally, if you have more number of features, if you don't define this maximum depth, and if you have seen in scikit-learn, by default there is no parameter there. Okay, no value there. It's none. So it will take its own time, to construct the entire tree. It will pick up every variable and it will try to use that particular variable, and it will make sure that in every leaf node, and in the leaf node there is only one minimum is one observation. So it will try to match to the training data set that every observation is properly classified or not. For every observation, it will try to come up with a different rule or different conditions which will help that particular observation to be classified correctly. So in that case, it may overfit on your training data set. And the problem with an overfitting with overfitting is that if it learns too much from the training data set, it may not perform on the new data set because it will learn all the small patterns and variation in the training data set, which may not be same in the test data. You know, it's, so it would be similar, but it may not be exactly same. So instead of learning too much, if it can generalize at a high level, then your model would be more robust. It may not give you 100% accuracy, but on an average, it will give you 80% and 90% accuracy. That's what we want. If it learns too much, it may give 100% on your training data set, but on your new data set, it may not work well. Okay, it may not give you the right prediction. So that's the reason this overfitting needs to be dealt. So it can be dealt before training the model by restricting the tree to certain limit, or else you can allow this tree to grow to the fullest, and then finally you can prune the unwanted branch from that tree. So here I'm going with the maximum depth is equal to 4. For now, as I do not have a big data set, so this would be fine. And now once I initialize this algorithm, then configured all these parameters. Now I'm going and fitting on my training data set. So once the training data set, it has fit on the training data set, then I can go and predict. So this is a very common same code like model.predict it and pass the test data set. It will give you the predictions. Okay, now comes your evaluation. Uh, in the naive base, there is a uh, comprehensive code, right? So you can pick whatever I haven't used here, the evaluation, you can pick that code and you can run it here. So here I'm just using the accuracy score, but all that precision, recall, whatever we have discussed in the initial use case, you can use all those here as well. Okay. So see, the accuracy score on the test data set is coming out to be 98%, which is pretty good, right? So I'll just show you how the visualization look like. So this is how, the tree has been formed. See how nicely it has created this particular tree. So I'll just reduce the font size so that I can fit this entire tree here. Okay. So first it has picked up, this particular column, which is a numerical column. Sodium to potassium. Okay. And it has come up with this particular rule. If the sodium and potassium level is less than equal to 14.615, then if it is true, then all the observations will fall here. If it is false, then all the observations fall here. Okay. So the observations which are falling here, so the total samples were 140, and here it's 69, here it is 71, right? So all the 69 samples which are falling in this particular node, they have been given drug Y. Okay. So this is a very pure node. Okay. There is nothing ambiguity here. Okay. And there is no other than, drug Y, nothing is there. So Guinea score is perfectly zero. So here, no need of further split, and it is a pure node. So here the decision can be made, okay, when any observations falling in this particular node. So here, whatever observations are falling 71, they are being tested on another condition, like if the BP is less than equal to 0.5 or not, okay, and then, you know, it has, uh, again, it has been further split. Is there any multiple drugs into it? 1 second. Yeah, you have multiple drugs here. So Guinea worked on the multiple classes. So, but yeah, but all this split is binary if you see. Okay, so in any split, there is not more than uh, two, two output. So there's a reason Guinea worked here. Okay, but here the classes are more than two. So it's not just X and Y, it's X, Y, and A, B, C. It's multiple drugs. Okay, so it's a multi-class classification problem. Okay, so here the majority is drug X, but again, it is not a pure node. It is Guinea is 0.685. Again, the Guinea also lies between 0 and 1. Okay. So if it is close to 1, that means it's highly impure. If it is close to 0, then it is pure. Okay. So if you will notice that at every split, the Guinea score will get improved. Okay. It will get reduced overall. So here the BP is taken as a second most important attribute, and based on this particular condition, the data is again splitted into two parts. So here 27, here 44. So Guinea score has reduced, which is good. But again, it is not pure. So again, it has taken one more condition on age, and then again it has splits. Now these two nodes are perfectly pure. Okay, it has only one class in it. So here it is all class of drug A, and here is all are from drug B. So this is done. So here it has taken another variable, cholesterol, and then again it has picked up BP, So this is, one variable can be also, it will check, whether again that variable can be used, for further classification. Okay, so that also it does. So again, it has taken the BP, and again it has, because in this particular, uh, earlier it has taken this particular level, and then again, so it is greater, right? So this is the greater one. Even if it is in the greater side, again, it has checked whether this BP is less than equal to 1.5 or not. If it is less, then this is drug C is given. If it is more, then drug X is given. Okay, so now all these terminal nodes, if you see, these are all with a Gini score of 0. So that means these all nodes are pure nodes. So how it will work? You bring any new observation. I'll first check this condition. If it is true, then I will check this condition. If it is true, then I will check this condition. And then based on this condition, I can decide whether that person should be given a drug A or drug B. So like that, it is very good for the classification problem, and generally in the real scenario, if such kind of rules needs to be defined, and based on that, if the classification needs to be done, then decision tree is the very good model which you should try, okay, for solving that particular problem. All right, so this is a very simple code. Now I will show you on the hyperparameter optimization. Okay, so here this is, so in short, it is called as HPO, so hyperparameter optimization. Again, this is a very important topic. So in every algorithm, you have seen that there is some parameter which you can use to tune your model, right? And just note it down in one sheet of paper separately for every algorithm. What are the parameters which we can use, to fine tune the model? Because training is one aspect and fine tuning is another aspect. So training, anyone can do it, right? For fine tuning, you need to have some understanding about that algorithm, how it works, and you need to have an experience in terms of optimizing those particular parameters. So in the interview, people will stress a bit more on the this hyperparameter tuning part, right? So clearly note down for every algorithm what are the different hyperparameters which can be used, to tune the model. So here in this case, as we have seen, those are the three most important parameters which we can tune, okay, to get a better tree, okay, or better model. So here in this model selection, we have this two different techniques known as randomized search CV and the grid search CV. Okay, so CV means cross validation. So here, what will happen is in the randomized search, it will randomly take certain values and it will run multiple iterations, um, and it will validate. It will give you the accuracy score for every run, and then you can select the iteration at which or select the parameter values at which you got a better accuracy. In the grid search, you can define the range. You can say that, okay, maximum depth, take it somewhere from 5 to 10. Okay, so it will take, and let's suppose there is another parameter like minimum sample leaf, right? So there you can take a range like from 2 to 10, let's suppose. Okay, so it will take multiple combinations that it will create the complete grid. So here in this maximum depth, you have five different values which it needs to try, and there in the minimum samples leaf, plus suppose you have another five values. So 5 into 5, 25 different combinations it will create, and it will run 25 times, and it will give you the best combination. Just a second, guys. Okay, so these are the two techniques which we'll try, and rest everything I think you know about it. Okay, label encoder we have used, train test split we have used, accuracy score confusion matrix we have used. Okay, yeah, this decision trees I missed out. So here, if you go and see, this decision tree classifier is the function which comes out from this particular module, sklearn.tree. So in sklearn, what they have done is they have built a different module based on the different kind of algorithms. So these algorithms are from us. So there is a family of algorithms. Okay, one is like linear model family. Okay, there you have seen linear regression, logistic regression. Okay, there is a probabilistic based algorithms. Okay, and you have seen, right, we have naive Bayes. In that, we have multiple different kinds of probabilistic algorithms, right? Now we are seeing a tree, right? So all the tree-based algorithms, you will find it in this particular module. So there are many more models, okay, algorithms under tree module. But the most popular one is the decision tree. So in this, you have again two different algorithms. One is decision tree classifier, and another is decision tree regressor. In the regressor, by default, there wouldn't be any kind of choices of criteria which you have to set. By default, it will take variance into consideration. Okay. So nothing you have to do is, if it's a regression problem, you just say where it is. Yeah, you just call decision tree regressor. You don't need to pass anything. You can just here you don't need to pass anything. Here you just need to pass maximum depth, all those parameters, and just fit it on the training. So that's all. Okay, and you can able to uh, predict the numerical values. Okay, now let's look into this. So here I am taking another healthcare life sciences related data set. It is more around predicting whether the person is having a heart disease or not. Okay, so so there are multiple categories here. So again, this data set, if I remember correctly, it is taken from UCI. Okay, so uh, 1 second, I might have done something here. Okay. So here I've just considered only these two categories, 0 and 1. So 0 means not having heart disease, 1 means having heart disease. There is 2 is something like who is having a risk of heart disease. There was another third category, but that's something we have ignored. So we have converted this data into binary classification problem where we have just taken 0 and 1. Okay. So now I'll show you, how I have done it. This hyperparameter optimization. Uh, so here I'm not using any kind of parameters here. I'm going with the default one. So this is how, it has given me such a big tree it has created, right? Okay, so I'll share this code. You can run and you can see it. So now what I will do is, now I will go and try to improve try to reduce the size of this particular tree. Now, this particular tree, once I have grown it to the complete length, full length, see what is happening. Okay, on the training, see, it is getting 100% accuracy. So what it's trying to do is, for every incorrect classification, it is also trying to correct it. Okay, and it is coming up with a separate rule for those particular observations. So it is not leaving any single observation to be misclassified. So that's the reason in the training, on the training data set, the score is 100%. On the test, it is getting 78%. So it is kind of looking like a overfitting problem here. Okay, it's an overfitted model. So what we will do is we will try to, and this is a confusion matrix. Now I'm using here uh, certain parameters which I will use to optimize the size of the tree. Okay, and this we call as a pre-pruning, means before allowing the tree to grow to the complete length and then pruning it. I am kind of restricting it beforehand. Okay, so that's the reason it is called as pre-pruning. Otherwise, it will call as post-pruning. Okay, so here these are the three parameters which we have seen, right, in sklearn documentation. So here the maximum depth, I'm giving certain values. Okay, I'm saying, okay, let's see at the maximum depth of 2, 4, 6, 8, 10, 12. Okay, and then I'm also giving certain values for the minimum sample split and minimum sample sleep. And here, as I'm explicitly giving them a range or giving them multiple values, so here I will use a grid search. First, I will initialize this particular algorithm, and then I will pass it to this grid search CV. In the grid search CV, I have to pass the model name, okay, the estimator, and then I have to pass this parameters. Okay, so this is known as parameter underscore grid, and I'm passing this particular object, which is this. Okay, so this is this should be in the form of dictionary where you need to have a key. Key represents your parameter name and the values. Okay, and then you use this particular uh, grid search CV object to fit on the training. So what will happen is it will run multiple times. So you have around 1, 2, 3, 4, 5, 6, 6 into 3 into 2. So that many different combinations it will try, and it will come up and it will give you the best combination, which is giving you the best result. Okay, so here it is. 1 second. Somewhere I'm not printing, what is the best parameter it has considered. Yeah. So here, if you say um, this GCV dot best estimator underscore, now it will give you the best model out of all this. Okay. So out of all the combination, whichever is giving you the higher accuracy, that model will be saved inside this object GCV as the best estimator. Okay, so this estimator is this particular algorithm, right? So multiple models will be trained, right? So at every different combinations of these three parameters, multiple models will be built, and then along with that, the accuracy will be also measured for that particular model. So if you just say GCV dot best estimator, out of all those models, whichever model is giving you the best accuracy or the highest accuracy, that will be considered as the best estimator. So from this GCV object, you select the best estimator, which is giving the higher accuracy, and then use that particular values of parameters, and again fit it on your on your training data set. Okay, so this particular three lines of code, okay, where you are passing the parameters, passing the estimator, and then fitting it on the training data set, and then selecting the best estimator. These three line of code will give you the best parameter values, which you should use, to train your decision tree algorithm. Okay, so once you have selected this, if you print this, it will show you, which of the parameters values it has considered, and then you fit it on your training data set. After that, you know what to do. Okay, you go and predict, you can pass the training, you can pass the test. Now if you see, now it has been balanced. Now the training score is 0.84 and the test score is 0.82. So now this is okay, right? Earlier I was getting training accuracy as 100 and then test accuracy as 78. Again, the good advantage with this is where earlier I am building the tree to the full length. It will again consume a lot of compute, a lot of resources would be required. If you are dealing with a larger data set, it will take a lot of time. In that time, you can run this cross validation, okay, technique, and you can choose the best parameters, and then you can have a pretty good model. Okay, so that's the reason instead of going with the post pruning, we always prefer pre pruning. Okay, this is better because it is quick. It is quick, and it will also solve this overfitting problem, right? Rather than going with a bigger tree and then doing the post pruning, so that would take a lot of time, to process. So any questions so far? Now, if you see, it's a now the length of the tree is a bit small, so it has just taken 1, 2. the depth of 2 only. It has taken only the depth of 2. So with that, we got around 82% or 83% accuracy. Earlier, when my tree was like this, okay, such a big tree, okay. Still, this is okay, but in some of the cases, we get a very complex tree, okay, with a depth of more than 20 and 30. So that is quite complicated. And see, even the business would not like to have those kind of trees because one single variable may repeat multiple times, and there would be a very complicated rules, associated to every uh, labels. So every different scenarios. So if you keep it simple, if you keep it short, then your model would be more better in terms of generalizing the scenarios and in terms of giving you the average predictions accurately. So in that way, keeping short and simple is always better, okay, rather than going with a very complex models, which is hard to understand and digest. So here, if you see, when compared to that particular tree, this looks very simple, and it is giving you 82 or to 83% accuracy. So this is good, right? And it has generalized well. It is giving the 82% accuracy on training as well as on the test. So in that way, I'll prefer going with this particular model rather than the previous model. Okay. So I've also included the post pruning technique here in case if you are interested, but I would not prefer this because generally we go with the pre-pruning only. So in the post-pruning, you use this cost complexity pruning path. This is again one of the function inside this particular model. CLF is the model name, and here you pass the training. So what it does is it will take a different complexity threshold values, which is information gain, right? So this complexity parameter will be compared with the information gain. Wherever the information gain is less than this particular value, it will go and prune those branches. Because if the information gain is not significantly higher, then it's of no use of having that particular branch. So it consider that particular branch as unwanted branch and it will go and prune. Okay, so here it has considered various cost parameter alpha values. Okay, and for every alpha values it will go and find out at which what is the number of nodes and what is the depth. Okay, so here these are all the complexity parameters at which it will decide how many number of nodes it has allowed and how what is the total depth. Okay, so wherever there is an elbow kind of a turn, okay, in these graphs, you can consider that as a better alpha value and you can go ahead with that. So here what I did is yeah, so at different alpha values I calculated the training accuracy and the test accuracy. So these alpha values, if you understand, these are the alpha values which I am using once the tree is built fully. Okay. And then I'm using this alpha value or this complexity parameter value to cut the branches from the bottom, right? So at various complexity parameter, I may cut different number of branches. So, so in that way, the number of nodes would be different at different complexity parameter values, and even the depth of the tree would be different, which I have examined here in this particular graph. So at this particular value of alpha, what is my depth and what is my number of nodes, right? And here what I'm doing is I'm checking the training accuracy and the test accuracy. If you see here, if I am growing this tree to the fullest, okay, this is what I am getting, right? In the training accuracy, I was getting 1, and the test accuracy, I was getting 0.78, right? It is the full length. So there I am not pruning any branch. But when I started pruning, if you see that my test accuracy is increasing and my training accuracy is decreasing. So it is kind of resolving that problem of overfitting. Overfitting means if you have a huge difference between your training accuracy and your test accuracy, which is happening here, right? So here we are at a stage where we are having a overfitting problem. Slowly we are converging. We are making this training accuracy and test accuracy closer, right? So at this particular value, somewhere here, it's I've considered it as point 0.02. So I've considered this, but you can consider somewhere like this, okay, point 0.019 or 0.018. Okay, that would be better because at here at this point, the training accuracy and the test accuracy are quite, similar, okay, and they are quite near to each other. Okay. So in that way, you will get a more robust model. Here, the training accuracy is also high and your test accuracy is also high. So once you identify that alpha value, you put it here. Okay. So what it will do is, and you have seen in sklearn, there was one more parameter as CCP underscore alpha. So once you use this, what it will do is it will first build the entire model, entire tree, and then at this particular value, it will start pruning the tree from the bottom. Okay. Now use this, and this is what you are getting: train score and the test score, which looks okay. And this is how your tree looks like. So in the pre-pruning, we have seen that it went till the depth of 2, but now here it is going the depth of 3, right? So if you want to improve a bit, okay, so you can use post pruning, and it will improve the accuracy a bit more, okay, because you are growing the entire tree completely and then pruning. So you may get a bit better accuracy in that matter, but usually prefer pre-pruning. If you don't get a good accuracy, then you can try post-pruning, uh, because it's time consuming. If I have to run this here in this class, it may take few minutes, to run the entire code, okay, entire this post-pruning code. Okay, so to avoid that, you can go with the pre-pruning. Pre-pruning is fast and quick, and you can easily able to get the better model. So yeah, so let me know if you have any questions. Is it clear to everyone? Pre-pruning, post-pruning. So primarily in the decision trees, you will be asked a couple of questions like what are on the criteria on the Gini score entropy. They will ask you what is this entropy, how decision tree works, how it identifies the pure nodes, and all those questions they will ask, and then they may ask you uh, question related to pruning techniques. They may ask you the question related to hyperparameters. What are the hyperparameters? How you will prune? How you will address the overfitting problem in decision trees? So these are the typical questions which they may ask. Okay, when it comes to decision trees. So is that clear, everyone? Any questions? Any doubts? See, you guys have to play a lot with these algorithms. So in one single class, I may not cover every aspect. So you can go and try changing the parameter values. You go and try changing the criteria, like Gini, or you can change it to entropy and see that what kind of changes you are getting. Is there any change in the decision tree? Is there any change in the rules? What has been identified when you have used Gini and now when you are using entropy. Okay, so those kind of experimentation, you please do it so that you will get a good understanding on this entire particular algorithm. Okay. And I also shown you different sorts of data sets. Okay, you can go to UCI, you can go to Kaggle, you can download the data set and then you can try. Okay. And I would also suggest, I don't know how many of you are practicing Python. Whatever notebook I'm sharing that with you, just don't run it, okay, just by clicking run button and then seeing how it is running. Already I've done all that bug fixing, all optimization. I've done it. So that's the reason it may run smoothly. But you will learn Python code when you start coding yourself. Okay. Try to code yourself. One, take one use case and see that how the coding has been done. But for the other use case, I would rather suggest, code yourself. When you try coding yourself, you may get a lot of errors. And once you get the errors, if you understand how to fix those errors, now that's where, you will learn programming. Okay. So if you are not getting any errors, if you are not fixing any errors, then you are not a good programmer. The good programmer is not the one, who writes a code without bug, but the good programmer is the one, who can fix any kind of bugs, right? So bug fixing is the most important skill for any particular programmer. So even when we are working on any of the use case and when we get stuck somewhere, when we get a lot of errors, okay, so usually we go to a person who can fix those bugs quickly, and we have excellent people in the team who can fix any kind of a bug very quickly. Okay, so those are the good programmers because those are the go-to person who can help us when we get stuck somewhere. So how you can fix those errors? If you understand the complete programming part correctly, if those are like syntax errors, that means you have to practice more on and learn more on that syntax part, right? How for example, if you miss here in sklearn dot preprocessing, if you say sklearn underscore preprocessing, those are known as syntax errors. In the error, you can easily get, what is the problem with the code, and you have to go and fix that. But sometimes, in building the logic, you may go wrong. Okay, for example, if you are building a function, okay, in the function, if you miss out indent, if you miss out certain logic, again, you will get an error. So those errors would not be very explicit, okay, when you get the error. So how you will fix those errors, that is again becomes very important, right? How you will understand. So learn about it. If you are not sure, take that code or take that error, put that into Google search. Okay, see that, how others have fixed those code. Go to Stack Overflow. Stack Overflow is the favorite spot for every programmer, to understand how to fix any particular error. Okay, so it's a very good platform, for all the developers to seek some help, whenever they get stuck anywhere in the programming. Right now, you have ChatGPT also. You can leverage ChatGPT also. People are leveraging ChatGPT. But again, um, I'm cautioning you, even if you are using ChatGPT, do not paste your customer code into ChatGPT. There was a news. One person in some company, okay, I'm not remembering, it's a Samsung or some other company. What that particular person has done is he has taken the entire confidential code of the company and he put that into a ChatGPT. So what ChatGPT does is ChatGPT take all the information which is publicly available, and that model has been trained on that. So even when you ask something or when you upload something into ChatGPT, again it will be taken uh, outside your environment, and it will be used. It will be published somewhere outside in any of the website, right? Because that's a more general code. So what ChatGPT has done, it is now that particular code which was very confidential. This person has pasted that into ChatGPT console. Now that code is lying in the ChatGPT knowledge base. Now somewhere, some other person, he has a similar problem and he's typed, in ChatGPT like, okay, I'm facing this problem. Can you suggest me some code? And ChatGPT has suggested the same code, okay, which this person has uploaded there. Okay, and it was a complete solution. Okay, the confidential solution which that company was building, it was now publicly available to everyone. So that's how, you have to be very careful even when you are uploading the code or the document to the ChatGPT. ChatGPT is a very open source, right? So your data would not be secured. So in our company also, this ChatGPT and everything, they are very limited people are using, and otherwise it is kind of banned internally. So we cannot use and we cannot paste any code on ChatGPT, right? So so again, coming back, so please practice programming as well simultaneously. You will love it, okay? Because Python is not that difficult. If you keep typing and if you see that your code is running and you are able to fix the bugs and errors yourself, automatically you will gain that confidence. And if you try using different data set and if you come up with a good accuracy, again, your confidence will boost up. So try doing that. If you do it continuously, okay, so you will get more comfortable with this, and that will definitely help you, okay, in future. So anything else, guys, you would like to discuss? So tomorrow we will talk about support vector machines. So from here onwards, these kind of algorithms will become a black box method. Now, SVM, support vector machine, it's a more sophisticated machine learning algorithm, which may give you a better accuracy, but the explainability and interpretability of that particular model would be very low, would be very less. You cannot able to explain that model. So we call as a black box models. And after that, we will talk about neural networks. So that is also one of the black box methods. So this is something like it, we call it as a magical box, okay, where you pass your input data, it will give you a pretty good results, okay, accurate results. But what's happening in the box, you cannot able to visualize or you cannot able to understand. So now decision tree, we understood, right? How it is constructing the tree and how it will make the predictions, that is clearly understood. It is an explainable model. But when we go to these support vector machines or this neural networks, the things would not be that easy to understand. Yeah. But so wherever if the accuracy is the prime important thing to achieve, then you can go ahead with support vector machines or neural networks. And after that, in the end, we will talk about ensemble learning models. So ensemble learning models is here we are at a time we are using only one single algorithm, right? In ensemble, we can try multiple algorithms together and we can improve the accuracy. So all that, we will discuss in the coming days. So here, literally, I don't want to rush. I don't want to take another topic now. So I want to go a little slow here. So please practice whatever code I have shared. Please practice, okay? And if you have any questions, do ask. I see that you guys are not asking questions. I'm not sure whether you're practicing or not. So my humble request is take out time, please practice. Otherwise, later you will repent, okay? Later it would be difficult for you to cover all these topics. Okay. So, all right, then we will connect tomorrow then. Okay. I'll share the code. Thank you guys. Take care.